Let's jump into some physics. Whoa, some motion, right? Really what calculus was all intended for was to be able to describe how things are moving and changing in this world. Classic problem here. We're told the ball is thrown vertically upwards, boing, from a height of 20 feet with an initial velocity of 14 feet per second. That's the velocity at time 0. So you can think of it as v of 0 equals 14. Use a of t equals negative 32 feet per second as acceleration due to gravity. We're going to ignore air resistance to answer the following questions. So we're asked how high will the ball go? When will the ball hit the ground? All these questions that require us to, well, if we want to know how high the ball will go, we need to know the position function, right? We need to know the height function. We're given acceleration. So we have to go from acceleration to velocity, and then from velocity to position to answer these questions. So before I even go forwards, let's find our basic, equations. I know that v of t will be equal to the integral of a of t dt. All right, so if I integrate a of t, that's going to be integrating negative 32 with respect to t. The derivative of what gives me negative 32 with respect to t? That'd be negative 32t plus c. So that's equal to v of t. Now, to figure out what c is the initial velocity. How do I know? Because if I plug in 0, I'll get out 14. That's what we're told. And if I plug in 0, this all goes away. 0 times negative 32 plus c. So c is 14. And a lot of extra work there to just say that the velocity is equal to negative 32t plus 14. Okay, so this is your velocity equation. I'm going to put that in a box. Well, we also need the position function. So we're going to integrate velocity because the derivative of position is velocity. Its derivative is acceleration. We're going backwards. Knowing that we have to go backwards is what tells us we need to integrate. So we'll integrate the velocity. And so that will be the integral of negative 32t plus 14 with respect to time, just like x, but a different variable. And so we'll integrate each of these. So the integral of negative 32t, that's going to end up being negative 32t squared over 2. Right? If you need help on the integration, go back to the earlier videos. Plus, the integral of 14 is 14t plus an original constant that we don't know. Now this again is the height, or the position function. A lot of teachers will call it s of t for position. I'll call it h of t for height. Okay, we simplify this thing down, and keep in mind that the initial height is 20 feet. So when I plug in 0 into here and here, these will cancel, leaving me with 20 for c. And you'll see that in a second. You get negative 16t squared plus 14t plus c is the height. This is actually the longest part of the problem, is doing this out. When I plug in 0, right, that's what the initial height will be when time is 0. This goes to 0 because it's got a t. That goes to 0. And we get out c, which is equal to, we know, 20. Nice. And so what we end up with is h of t, right, c equals 20, is equal to negative 16t squared plus 14 a t plus 20. So that right there is our position function. I'll circle that one. So now we've got the position, the velocity, and the acceleration is given to us. So let's go through and let's answer some of these questions. So now that we've got our equations, we can use them. And these questions are actually older questions. How high will the ball go? Okay, well, the ball will go as high as its maximum height. When will the maximum height happen? This is going to happen when the velocity is equal to 0, because we're going to go whoop, stop for a moment, whoop, and then fall. So we're going to set v of t equal to 0. And by the way, in terms of simplifying our answers here, you're definitely, probably going to want a calculator nearby, though you don't have to use a calculator here. I'm going to do something annoying, and I'm going to have to calculate it as we go. So we set the velocity equal to 0 so that we know when we're at the top. So at what time do we hit that maximum height? That's going to be when that's equal to negative 32t plus 14. I subtract 14 and divide by negative 32, and I'll get 14/32. Ugh. Well, I guess that's going to equal to 7/16, which, let's do that as a decimal. 7 divided by 16 is 0.4375. So 0.4375 seconds. That's how long it takes for the ball to go whoop and stop. That'll be the max height. Now, sorry, that'll be the time when the max height happens. We want to know how high the ball will go. So now that we have the time when we reach our max height, we're going to take that and plug it into our position function. That'll give us the height. So h of 0.4375 and we just plug it into the calculator. And what I'm going to do is magically come back to you with the answer once we plug it in. And through the power of very bad video editing, we've got 23.0625, and that would be in feet. Again, I took the time when we reach our max height and plugged it in. When will the ball hit the ground? Well, the ball hits the ground when it goes whoosh, right when the height is 0. So I set h of t equal to 0. That would be when we have negative 16t squared plus 14t plus 20. Now what I would do is I would use my calculator and calculate where this curve crosses the x-axis when t is greater than 0. Again, I'm going to do that calculation and I'll come back to you with the answer. And magically the answer appears. So we've got 1.638, and that would be seconds. And again, the only work that you have to show if you're doing this on the A, B, or BC exam is literally your setup. And you could be asked questions like these. So you show what you're setting equal to 0. You don't have to solve it out. Just get a decimal. And then show that you're plugging it in, get out the number. Same thing here. We hit the ground when the height's 0. We plug it in. We get out an answer. Okay, let's go to C. What is the velocity of the ball when it hits the ground? Well, the velocity of the ball when we hit the ground is the velocity, which is v of t, at this time. So it'd be v of 1.638. So all I'm going to do there is literally plug take negative 32, multiply it by this, and add 14. I'm going to do that on my calculator right now. We're not even going to do any editing for that because it's a quick enough number. So it's times. Now I use the actual x value that I got in my calculator. And I get negative 38.419 if you're rounding up. And that would be in feet, because it's velocity, per second. Again, I'm using the number I got on my calculator, and I'm showing 3 decimal places, but using the much longer decimal in my calculator just in case there's rounding error. Remember, on the AB and BC exam, you need to have at least 3 decimal places, either rounded or you could do what's called truncate and just not round. Just do the 3 decimal places you see and chop it off. Or more is fine. Okay, let's keep rocking and rolling. Now, I'm going to go to the next page, but it's still the same problem. And so that says, is the velocity of the ball increasing or decreasing at t equals 1? Well, remember what we have for velocity. Velocity was v of t. Well, hold on a second, actually. Let's think about this. Do we need velocity? I'll write it out. We got negative 32t plus 14. But here's the thing. That velocity that we have, we're not asked about what the velocity is. We're saying, is the velocity increasing or decreasing? So what I would say is, since we need the acceleration here, so since v prime of 1, we want the velocity at 1, which is equal to the acceleration at 1, what's that equal to? Negative 32. Since that's equal to negative 32 feet per second squared, which is less than 0, then we can say that v of t, or the velocity, so the velocity is decreasing at t equals 1. And please don't abbreviate like I did. All right, that's it for that one. And letter E, is the speed of the ball increasing or decreasing at t equals 1.5? Here we need velocity and acceleration. So let's just find both. We've got the acceleration at 1.5 it's always negative 32, right? It holds constant, is negative 32. Velocity at 1.5, we'll have to plug that into our function here. And so I'm going to go ahead and do that. 1.5 times negative 32 plus 14. That gives me negative 34. So since a of 1.5 is less than 0 and v of 1.5 is less than 0, we've got same signs, the speed is decreasing. And I'll just copy everything here. The speed of the ball, is increasing. I said decreasing, is increasing at t equals 1.5. Remember, if the signs of your velocity and acceleration are the same, speed increases. I misspoke there. So speed increases for this problem. That's it. The actual only integration we did was in the beginning of this problem, where we had to integrate to figure out the actual values from a of t to v of t to position. That's pretty massive right there. All right, for those of you that have already studied some physics, we just derived, with integration, some of the kinematics equations, right? Your motion equations. Sick! You know what else is sick? The exercises that are coming up after this video. Peace.